In our next video, we're going to use our inverse trig functions to evaluate and find angles for ratios that are not special. Negative 5/8 is not a special ratio like 1/2 or -1 or 0 or √2/2 or 1 or -1 or square root of 3, etc. So we could draw a picture. The directions in these sections also gives you a little bit more information of what they're looking for. They want our angles to be in specific quadrants. Now 180 to 270, the first thing I notice is 180 to 270, that's the third quadrant. No inverse trig function will ever give us an output in that quadrant, ever. So we're going to need to figure out how to adjust this. Just so you know what this really means. I don't know what my triangle is actually going to look like because it depends on what the reference angle is, and that's what we're looking for. We're looking to find this value of theta. What this means is the opposite side divided by the hypotenuse is 5/8. So we could label this y-coordinate as -5 and the hypotenuse of 8, but then it wouldn't fit within a unit circle. Another way to do this is to divide both of these by 8, so it becomes a unit circle when you shrink it down. I'm not sure the picture is actually necessary to do this because we have inverses. So here's what we do know. The sine of the angle we're looking for is -5/8. In order to find the angle, I need to undo the sign. I can't just divide it because it's not multiplying, it is a function. So I'm going to apply the inverse function of both sides. So let's do sine inverse of the sine of theta, which is going to give us theta. Then I'll do the sine inverse of -5/8, and let's see what this gives us. Now I want my answer to be in degrees, so I'm going to double check my calculator is in degree mode because it says it's an angle between 180 and 270 degrees. So let's type sine inverse. So we're going to use the secondary sine function, so second sine. So I don't know if you saw that, so second sine. And then I'm going to type in -5 divided by 8. Close my parentheses, it's good habits. It gives me an angle. My theta angle is going to be approximately 38.682 degrees. Problem with -38 degrees is it's in this fourth quadrant. So that means that the right triangle I'm looking for has that as a reference angle. Well, in order for this sine length to be the same thing, it's going to have the same reference angle. So the absolute value of this reference angle is 38.682. So I'm going to continue moving from 180, 38.682 more than that. So let's do this. Let's take 180 degrees and add a positive 38.682, and this will approximate the answer we were looking for. The theta is approximately 218.682 degrees. It falls between 180 and 270. If I checked it, second answer, I get -6.2499. And what is -5/8? Okay, yeah, like -0.625. Yeah, that's pretty close. We had to approximate it because it's not an exact answer. We needed a special ratio to do this. So exercise 2, solve the equation. The cosine of theta is 0.4 between 270 and 360. 270 is down here, 360 is here. Cosine inverse only gives you an output between 0 and 180, so we're going to have to adjust this. The cosine is positive 0.4 in this quadrant, so I am going to draw a generic right triangle with a reference angle in the fourth quadrant and label 0.4 and 1. So again, we can use our inverse. Here's what we know. What undoes the cosine is a cosine inverse. So the cosine inverse of 0.4 should give us our answer. Sort of. Let's find out. Second cosine, and I'm going to put in 0.4. It gives us the reference angle is 66.422 approximately degrees. This angle would of course be in first quadrant. That would have the angle of 66.42. These share the same x side. It's like the reflexive property in geometry. They have the same x value, but they're different angles. This angle would have the same reference angle in that fourth quadrant. The answer could be -66.422. That's the same reference angle in this fourth quadrant. But does that fit the answer where the answer needs to be between? No, it does not. So what I need to do is, instead of going backwards, let's go starting from 0 all the way around and stopping at the same terminal side. That's 66.422 away from 360. So I'm going to start at 360 and I'm going to minus, or go backwards, 66.422. 66.422. This should get us our approximate answer. Theta is approximately 293.578 degrees. And if I check this by doing the cosine of that answer, it gets me, wow, that's pretty close to 0.4. That's as close as we need to get. So this is what we're going to do. I draw the picture just to basically guide me. It's not the best picture in the world, but to basically visualize what do I need to do to my answer to get it to be correct and fall within the range that we need it to. I'm going to try to do, I guess, maybe we'll try the left-hand side and let's see what happens. Now the tangent value, I think without drawing the picture, the tangent is positive somewhere in the first quadrant. We want it to be between 180 and 270. So we need to find this reference angle and then adjust it somewhere in this quadrant. Let's do the tangent inverse of 4.7 and see what happens. Second tangent inverse of 4.7. If I close my parentheses and enter, it's 77.989. So that gives me 77.989. That refers to this reference angle here. If I have the same ratio of adjacent side, opposite side, I draw this triangle. It looks like they're like 180 degrees apart. What's the reference angle of 77.989? Now I'm going to adjust this from 180, and it looks like we're going in this direction. That means we're going to add plus 180 to get 257. Theta is approximately 257.989 degrees as an answer. I'm going to skip 2 and 4 and 6. Let's go down to question 3. Let's see, between 180 and 270. 180 degrees, 270 degrees. Let's do the cosine inverse of negative 0.39. Second, cosine inverse, negative 0.39. Now this gives me 112. Theta is approximately 112.954 degrees. That corresponds to this angle, 112.954. Now I want the same cosine value. That means I must have a right triangle that shares that same side, but down here in this fourth quadrant. Maybe I should make my picture a little bit nicer for you. So originally I had some triangle in this quadrant, and the cosine value needs to be shared. So if I have the same x-coordinate, it will have the opposite y-coordinate in this quadrant. Problem is, I need to be between 180 and 270. I need to know what this theta is. That theta is not, I repeat, is not 112 degrees. I need to find the reference angle. So I'm going to take 180, subtract my answer that I got, the exact answer. That tells me the reference angle, I'm going to write theta reference, is 046. That's what I'm going to add to 180 because I'm moving in the positive direction. Let's add 180 to it. This gives us 247.046. So the angle we were looking for that fits between 180 and 270 is 247.046 degrees approximately. Last one we're going to do, the sine inverse. So we have a ratio, we want an angle. That means we're going to use the inverse, 0.62. So let's do second sine 0.062. This gives us approximately an angle, a reference angle of 38.316 degrees. Now that reference angle is in quadrant 1. We want the angle to be between 90 and 180. Drawing this picture just helps me. It's approximately 38 degrees, has the same y-coordinate. So I'm going to draw a triangle with the same y-coordinate, which means it's going to also have the same x-coordinate because there's something sort of called the hypotenuse leg. All the hypotenuses are the same in a unit circle. If this leg is the same, then these are two congruent triangles, which means corresponding parts. This reference angle is 38. Now, I'm not going to add it to 180. I need to subtract that reference angle because I'm going backwards because I'm at the end of the interval. So what I'm going to do is I'm going to take 180 and subtract the answer, subtract that reference angle. So it's not the same setup every time. This gives us our answer, 141.684. So the theta, the value we're looking for, is 141.684 degrees. Go ahead and try the evens if you like, but move on to the next video.